32 goats while Chebet had 56 goats. Chebet sold twice as many goats as Abdul. After the sale, the number of goats that Abdul and Chebet remained with was in the ratio 3:5 respectively. Part A of the question: determine the total number of goats sold by Abdul and Chebet in the market. So we go to the first statement where we have Abdul had 32 goats. So Abdul had 32 goats. Then Chebet had 56 goats. Chebet sold twice as many goats as Abdul. So because we don't know the total number of goats sold by Chebet and Abdul, we can let the number of goats sold by Abdul to be X. And since Chebet sold twice as many goats as Abdul, it will be 2 times X, and that will be 2X. So therefore the number of goats sold by Abdul will be X. The number of goats sold by Chebet will be 2X. Now after the sale, the number of goats that Abdul and Chebet remained with was in the ratio 3:5 respectively. So what we need to get is the remaining after the sale, what remained. So Abdul, we start with Abdul. Abdul had 32 goats, and therefore after selling X goats, this is what remained: 32 subtract X. Then for Chebet, initially Chebet had 56 goats, then sold 2X goats. So the remaining goats were 56 subtract 2X. This is the expression for the remaining goats. Now we're given that the ratio of the remaining goats was 3:5. That is Abdul to Chebet. So this is what you're supposed to have. So the ratio of Abdul, A for Abdul, then Chebet, was 3:5. So that means if I get this ratio, Abdul, which is 32 subtract X, divide by, that is the ratio, Chebet, that is 56 subtract 2X, that ratio should be 3:5. 3:5 can also be written like that. So this is the equation that you're supposed to solve in order to now determine the total number of goats sold by Abdul and Chebet. So we work out this, and we simply do this by cross multiplication. So we shall have 5 and then multiply by 32 subtract X is equals to, then 3 multiply by 56 minus 2X, like that. So when we multiply these, we will get this one. We open the brackets. This one will give 160 minus 5X is equals to, this is 168 subtract 6X. So like terms together. So we have, you can bring the x's to the left hand side, so that I have minus 5 minus 5x plus 6x is equals to 168 minus 160. So this will give x is equals to, and this will give 8. So x is 8, and therefore the total number of goats sold by Abdul, X, is 8, so 8 goats, and then Chebet is 2 times X, 2 times 8, it will be 16, and therefore now we can answer the question, the total number of goats sold by Abdul and Chebet. So total is equals to 8 plus 16, so that is a total of 24 goats. So that is how you're supposed to solve the first part. We go to part B. So part B of the question, Abdul and Chebet raised a total of 97,600 from the sale of goats at the market. Abdul's selling price per goat was 5% higher than that of Chebet. Determine the ratio of the earnings of Abdul to Chebet from the sale of the goats. Now given that both of them raised a total of 97,600 from the sale of goats, then Abdul, I think the key thing is here. Abdul's selling price per goat was 5% higher than that of Chebet. So what we are going to begin with, we can let the selling price of Abdul, because you're given that Abdul's selling price per goat was 5% higher. So I can begin by letting, so we have Abdul and we have Chebet. So we can let the selling price of Chebet to be X shillings. X shillings. And then since Abdul's selling price was 5% higher, 5% higher means it is 105. 100 plus 5%, that will be 105 over 100 of Chebet, that is X, and this will give 1.05x. So therefore this is the selling price per goat of Chebet, that is X, and then Abdul, having sold 5% higher, it will be 1.05x shillings. So now after we get that, then from there we told that both of them were able to raise a total of 97,600. So initially from the other part we have the number of goats by Abdul. We got it. There were 8. Okay, there were 8 goats. Abdul had 8 goats, so don't forget that, 8 goats. And then Chebet had 16 goats. So after selling all these goats, they were able to raise this amount. So therefore we need to get the total amount each got, and then we add, and that will give us an expression that is going to help us to get X. So we start with Abdul. Abdul had 8 goats and the selling price per goat was 1.05x. So we start with that. So therefore Abdul had 8 goats, then we multiply by, now you're getting the total amount of money obtained by Abdul. 8 goats, selling each of them at 1.05x shillings. Then we add, Chebet had 16 goats and then selling each goat at X shillings. So that is the total amount she received. And when we add these, both of them were able to raise a total of 97,600. This is the expression that will help us to get the selling price per goat. So we work out these. 8 times 1.05, this will give so this one will give 8.4x, then plus 16x is equals to 97,600. We can add this. This will give 8.4x plus 16x. This will give 24.4x is equals to 97,600. So we get X. X will be given by 97,600 divided by 24.4, and this will give, using a calculator to work out this will give 4,000. That is 4,000 shillings. So 4,000 shillings is now what Chebet, look at Chebet. Chebet was sold each goat at X shillings. So that means she sold each goat at 4,000 shillings. 4,000 shillings. So we can now get Abdul's total amount and Chebet total amount, because now we have the value of X. We have the value of X, so we can simply get Abdul's earnings. Abdul's earnings by taking the price or the selling price of each goat, which is 1.05x. Actually should do it here. So Abdul, we have X is 4,000, So 1.05x, that is times 4,000, and this one will give for Abdul, it will give us 4,200. Then Chebet selling price was x, and we have already obtained x as 4,000. Now using these, we can now get the total earnings by Abdul, because the question is determine the ratio of the earnings of Abdul to Chebet from the sale of goods. So we need to get the total earnings of Abdul. So Abdul sold how many goats? 8 goats, and each goat 4,200. So total earnings, therefore this will be 33,600. Then Chebet had how many goats? That is 16. The selling price of each goat was 4,000. So when you multiply these, you get this one is 64,000. So now we have the earnings by both of them, Abdul and Chebet. Now let us get the ratio. Now Abdul to Chebet. So Abdul was 33,600, then Chebet 64,000, and this one will give, you just simplify this one using a calculator. When you simplify this ratio, you get 21:40, which can also write this one as 21:40. So that is the ratio. The last part C, Abdul decreased the selling price per goat in the ratio 19:21 for the goats that remained. Determine the new selling price per goat. So this one is quite straightforward. We have the ratio, and you can see the selling price decreased in this ratio. So we simply need to take 19 is to 21, then we multiply by the selling price. Abdul selling price was, Abdul's selling price was, let me go back to question. So Abdul's selling price was 4,200. We got that, 4,200. So for us to get the new selling price, because it decreased in that ratio 19:21, you simply need to take 19 divided by 21, then multiply by the selling price of each goat by Abdul, that is 4,200. You got it in the previous part, and this one will give 3,800. The price of pens in a bookshop changed in the months of February, March and April. The price of a pen was 2 shillings less in the month of February than, there's a spelling there mistake, than the price of a pen in the month of March. In the month of April, the price of a pen was 2 shillings more than the price of a pen in the month of March. The bookshop sold pens worth 4,200 in February. In April, pens worth 4,500 were sold. Take X shillings to be the price of a pen in March. Part A, write an expression in X for the number of pens sold in the bookshop in 1. February, 2. April. So we have February, we have March, and we have April. So we're taking X to be the price of a pen in March, and this will help us to find the expression of February and April. So let's go to the second statement. The price of a pen was 2 shillings less in the month of February than the month of March. This one is than the month of March. So that one can help us to write the expression for February. So if March, the price of a pen in March was X, then February was 2 shillings less. So that will be X subtract 2 shillings. Then for April, the other statement, in the month of April, the price of a pen was 2 shillings more than the price of a pen in the month of March. So in April, it was 2 shillings more. So in March, it was X. So if it was 2 shillings more, it will be X plus 2. So now we have written the expression for the price of each pen in the months of February, March and April. Now what we should now get is the expression in X for the number of pens. The question is the number of pens. Now what will help us to get the number of pens in February? We already given in the other statement here that the bookshop sold pens worth 4,200 in February, and in April 4,500. So this one will help us to get the number of pens. So to get the number of pens, we are going to take the amount, the total amount of money, then divided by the price of each pen. So for example, in February, if you want to get the number of pens sold, we are going to take the amount of money obtained from the sale of all the pens. That will be 4,200, and then we divide by the price of each pen, which will be X subtract 2. So that will give us the expression for the number of pens. For April, the same, the total amount obtained from the sale of all the pens in April, which is 4,500, then divide by the price of each pen, which is X plus 2. So those are the expressions for the number of pens for those months. Now after doing that, now we go to part B. The bookshop sold 50 more pens in February than in April. Determine the number of pens sold in February. So the bookshop sold 50 more pens in February. And we have the expression for the number of pens sold in February and April. So 50 more pens in February than April. So that means if I take the number of pens sold in February, that is 4,200 divided by X subtract 2, and I subtract the number of pens sold in April, which is 4,500 divided by X plus 2. That should give 50. Why? Because we told that the bookshop sold 50 more pens in February. So it means the number of pens sold in February are 50 more than in April. So if I take the number of pens sold in February, subtract the number of pens sold in April, I should get 50. Now that is the equation that you come up with, and now you need to solve this equation. You solve for X, and X will give us the number of pens sold in the price of each pen. It is here, the price of each pen in March, which will ultimately help us again to find all the number of pens in February and April. Now to get X, we're going to begin by getting the least common multiple, the LCM of X minus 2 and X plus 2. So that is where we're going to begin. So the LCM of X minus 2 and X plus 2, which is the LCM will be X minus 2, X plus 2. This is the product, and then we multiply each term by that least common multiple. So multiply each term, so we shall have X plus 2, X minus 2. We multiply that by 4,200, decide X minus 2, then minus, we have to do the same. For this one, we have to do the same. For this one is x minus 2, x plus 2, like that. And the right hand side again, 50, we multiply by x plus 2, x minus 2. So you notice x minus 2 and x minus 2, that one will divide out. So x minus x plus 2 and x plus 2, that will divide out. So that we be left with 4,000. This side 4,200 multiplied by x plus 2, subtract, we have 4,500. Here x minus 2 is equals to 50. Left with 50. Then x plus 2 multiplied by x minus 2, that is difference of two squares, and it will simplify to x squared minus 4. I repeat, x plus 2 multiplied by x minus 2, that will simplify to x squared minus 4. We continue working out. You can open the brackets here, so that we have 4,200x, 4,200x plus this will be 8,400 minus 4,500, then plus negative multiplied by negative, this one is plus 9,000, is equals to 50x squared minus 200. Now from here we can reorganize this by collecting the like terms together. We can collect the like terms together to form a quadratic equation. So when you collect the like terms together, this is definitely what you're going to have. So let me first take the ones without x. So this will give 17,400 minus for the x here is 4,200x minus 4,500x, that will give 300x, is equals to 50x squared minus 200, collecting the like terms. Then from there, reorganize this one to form a standard quadratic equation. So this will have 50x squared plus 300x minus 17,000 17,000. Let me see, confirm this one. How this is of 17,400. We have 8,400. Yeah, it is okay. 8,400. Let me confirm these 8,400 plus 9,000 is okay. 17,400. So 7 minus 17,400, like that, is equals to 0. I'm sorry, this one will give so we have 17,400 and then plus 200. There's something here noted here. This will give 17,600. I think that one is okay. 50x squared plus 300x minus 17,600 is equals to 0. Yeah, I've done that by bringing these on. So when you bring these on to this side, 17,400 plus 200. Now if you divide all through by 50, you will have this one as x squared plus this one will give 60. This one is 6x, and then 17,600 divided by 50, that will give 352 is equals to 0. Now we have simplified that, and now it is easier for us to solve this quadratic equation when it is like this. So we can use any suitable method, quadratic formula or factorization. So let me use a quadratic formula, whereby shall have a as 1, b as 6, and c as negative 352. So the quadratic formula, x is given by negative b plus or minus, we have b squared minus 4ac, everything divided by 2a. We substitute, so this will give, when you substitute, we shall have minus 6 plus or minus, this one is b squared is 6 squared, which will give 36, then minus 4 times a is 1 times c is negative 352, like that, then divided by 2a, 2 times 1, so this one will give minus 6 plus or minus, so we shall have 36, this will give plus 4 times 3, 52, 1408, everything divided by 2, which will give negative 6 plus or minus the square root of, this will give 444, like that. It is okay, divided by 2, so this one will give negative 6 plus or minus the square root of 1444 will be 38 divided by 2. So now having that, now we can proceed and get x. Remember, you get two values of x. You're going to ignore the negative one, since x represents the price, that is the cost or the price of a pen, so it can't be negative, and therefore the one that will give us positive here is negative 6 plus 38 divided by 2, the one that will give us positive. So if you consider negative 38, that will give us negative, so this will be 32 divided by 2, which will be 16. So you get two answers. The other one will be negative 22, so you ignore these and take, and then the other one is 16, so you take 16, so x is 16. So that is the price of each pen in March. Now the question is, determine the number of pens sold in February. So in February, we simply need to come here. So we have the number of pens in February. You just need to substitute here. This is the expression for number of pens. So 4,200 divided by x is 16, 16 minus 2, and this will give, when you work out these, it will give you 300. That is 300 pens. So we've answered the question for part B. So the number of pens sold in February will be 300, and we've done that by simply taking this expression for the number of pens in February and just substituting x. So that is how you're supposed to work it out. Now the other question, part C, determine the percentage change in the number of pens sold by the bookshop in April compared to the number of sold in February. So percentage change. So we already have the number of pens sold in February. So in February we just got it as 4,200 divided by 16 minus 2. That one has given us 300 pens from part B. Now we need to get the one for April, 4,500. It is here, 4,500 divided by x plus 2. So for April, 4,500 divided by x plus 2. So this will give 4,500 divided by 16 plus 2. And this will give 250. So we are supposed to find the percentage change in April compared to the number of pens sold in February. So look at the change. So in February 300 pens, in April 250. So the change is actually take 300 subtract 250. So the change is 50. So percentage change is equals to change, which is 50 divided by the original, that is the February. You're going to use the original as the February, that is 300, but then multiply by 100. Change divided by the original price. The original price in this case will be February. The original number of pens will be February, and then multiply by 100. So this one will give, when you work it out using a calculator, it will give 16.67%. Port S is 1700 kilometers on a bearing of 300 degrees from airport R. Airport Q is 800 kilometers on a bearing of 215 degrees from R. In the following figure, airport R is represented by point R. So the question part A, using a scale of 1 centimeter to represent 200 kilometers, show on the figure the relative positions of airports S and Q. So let's go to the first statement. Airport S is 1700 kilometers on a bearing of 300 degrees from airport R. So I'll first sketch it. So we have from R, we need to measure 300 degrees. Remember, for true bearing, we measure the angles in clockwise direction from the north. So this is what you're going to measure. 300 degrees means you shall measure it from this point from the north in a clockwise direction like that. So this is what you're going to measure. So 300 degrees. So therefore, the one that you'll be left with here will be 60 degrees, because the angles at a point will add up to 360. So this is the angle that you need to measure. So to simplify the whole of this process, you can just ensure that you measure 60 degrees on this side. By doing so, you'll have 300 degrees, because you measure it from the north in a clockwise direction. So that is what you're going to do accurately. So you just take your protractor and you want to measure 60, so sure it is straight. It's like that. So measure 60 from this end, so 60 this way up to this point, so 60 will be around there. So marked 60 there. So 60 is somewhere here. We'll mark it somewhere there, and then from there, now using a straight line, the point is here, 60. I made this point here, it is here. So there is 60, so you can confirm, you can place it there, just confirm it is 60. Yes, indeed, you can see it is 60 degrees. It is 60 degrees. So that is how you measure that, 300 degrees from airport R. So it is 1700 kilometers. So the scale you're given is 1 centimeter represents 200 kilometers. So what about 1700? You simply divide that by 200. So you need to measure, this will be 8.5 centimeters. So 8.5 centimeters, take that measurement. So mine is here. Mine is already marked there using my pair of compass. So it is well marked. So measuring 8.5. 8.5 is there. So that is 8.5. So mark it there. So that is S. So this is S. It is on a bearing of, and this is 8.5 centimeters. That is equivalent to 1700 kilometers. So we've measured this angle here. So that angle is the one that we've measured is 300 degrees. Then this one is 60 degrees. Then the other one, airport Q, is 800 kilometers on a bearing of 215 from R. 215 from R. So 215 means we're going to measure 180 and then we add 35. That is what is going to give 215. So 180, because we are measuring it from R, so from this point along this straight line up to that point we shall have, so from this point from the north in a clockwise direction we measure 180, that straight line, and then we add 35. So I'm going to simply add 35. So from this point here I'll simply add 35. So 35 is somewhere here, it is here. So this is 35. 35 will be there. So let me mark it. So 35 will be, let me mark it properly. 35. Yeah, 35 is there. So let me draw straight line. So 35, the point is here where we have 35, it is there. So using that point I'll draw a straight line. So from that point, so 35 is there. So this angle that is here, so this angle here is 35 degrees, and the whole of this is 180. So just look at it, 180 plus 35, that is what you get, 215. Then that distance is 800 kilometers. So how many centimeters am I going to measure? 800 divided by 200, that will be exactly 4 centimeters. So 4 centimeters, let me take that measurement, 4 centimeters. So take that measurement, 4 centimeters. Four centimeters, that is a 4. Yeah, that is 4. So mark it like that. So that is 4 centimeters, which is equivalent to 800 kilometers. So this is airport Q. That is airport Q. So we can now join S and Q to have this figure complete using a straight line. Using a straight line, can join it just to make it complete, and join it like that. Now the first part is answered. Using a scale of 1 centimeter to represent 200 kilometers, show on the figure the relative positions of airport S and Q. Now the next question is here. Part B, use the scale drawing to determine 1. The distance from airport S to airport Q in kilometers. SQ in kilometers. SQ in kilometers. So you just need to measure that. So you can use your ruler. I'm using my pair of compass. It is calibrated. So stand at this point here. So I'm taking this measurement. So I'm taking that measurement. that one is giving 9.1, exactly 9.1. So this is 9.1 centimeters. But since you're supposed to give the answer in kilometers, you need to convert that. Remember the scale, 1 centimeter represents 200 kilometers. So what about 9.1? Just need to multiply that by 200, convert it to kilometers, and this will give 1820 kilometers. Then the other one, part 2, the bearing of S from Q. The bearing of S from Q. So that means you need to construct the north at Q. You're measuring the angle from Q. And this one is very important, since you must have two nodes constructed at S and Q, and they must be parallel. So you construct the node at Q. To do this, kindly ensure you use your protractor to confirm that your node is actually 90 degrees, and the one that you construct also at S also 90 degrees, and make sure that the two nodes are parallel. So you construct a node here at Q. Sorry. For me, I'm able to draw a straight line without necessarily having a ruler. So there is the north. Mine is straight, so that is the north. That is the north at Q, and then you can also ensure that this angle here, like that, and then also at S you need to construct another node here. Sorry. Not yet. Yes, like that. Yeah, it is okay. So that knob, so ensure that this knob and this one, they are parallel to one another, and also ensure that this angle here, only construct here, this one is 90 and this one also is 90. You can confirm that one using your protractor. Now what you need to get is the bearing of S from Q. So we need to measure the angle from Q, and that angle is the whole of these. Let me identify the angle S from Q, this angle from the north all the way to this line. So that is the angle that you need to measure. So this angle from the north, we said you measure true bearing from the north in a clockwise direction. So this, from this point up to that line, that is what you need to measure. So in short, to simplify this, you can simply get 360 and then you subtract this angle that is here. 360 subtract this angle to simplify things. So 360 subtract that. So let me measure that angle, the small angle that is there. So that angle is this one is 30, 31, 32, 33. Is it 33? Let me check. So can place it. Check the way I've placed it there. Yeah, that angle is 31.
So measuring it from here, so this is 30, 31, 32, 33, around 34, around 34. That one is 34. So this is the 34 degrees. So this angle is 34 degrees. So the bearing, I simply take 360 minus 34 degrees. That is what is going to give me the whole of this angle. This is the required angle that we need to measure. So 360 subtract 34, and this will give 326 degrees. 326 degrees. So that is the solution for that part. So the bearing of S from Q is 326 degrees. Now we're done with that, we go to part C. An aircraft flying at a speed of 400 kilometers per hour left S for Q at 8 a.m. Determine the time when the aircraft was exactly 1000 kilometers from airport R on its way to Q. So we have an aircraft that is flying, that left S at a speed. So let's go to the diagram. You can see where S is. It left S towards Q. You can see where Q is at 8 a.m. Determine the time when the aircraft was exactly 1000 kilometers from airport R. So from these R, from here, exactly 1. So the aircraft is moving from S heading this way to Q. So you're supposed to determine the time. At what time was it exactly 1000 from 1000 kilometers. So 1000 kilometers, how many centimeters are those? So 1000 can convert that. 1000 kilometers, looking at the scale given, 1 centimeter represents 200 kilometers. So we divide that by 200, and this will give exactly 5 centimeters. So we need to take 5 centimeters and then we mark an arc standing at R, because we want to get at what time was it exactly 1000 kilometers from R, and 1000 kilometers is equivalent to 5 centimeters. So therefore, standing at R, we take a radius. Standing at R, we take a radius of 5 centimeters, and with that radius 5 centimeters, we mark an arc. We mark an arc at S on this line SQ, because this aircraft was moving from S to Q. So that is the distance. That is now with that radius from R to where we've made that arc, that distance is exactly 1000 kilometers. So if we join this point, so if we join this point using a straight line, we join this point, now that point, that is exactly this point of intersection there. So this is exactly 1000 kilometers, which is equivalent to 5 centimeters. So this is where the aircraft was. This is the point around here. So therefore the question is, you find the time when the aircraft was exactly 1000. So we need to get this distance from S to this point. This distance, we need to get this distance, and when you get the distance and you have the speed, you'll be able to get the time. So we measure this distance from S to where the aircraft was. That is exactly 1000 kilometers from R. So this is so let me measure that distance. We measure that. That is you need to be very keen when you are placing your So can see from a measurement there where that point is from A to S, that is 4.3, exactly 4.3. It is 4.3. centimeters, and 4.3 centimeters is equivalent to 4.3 multiplied by 200. Remember the scale given. This is 860. This is the same as 860 kilometers. That means the aircraft had moved from S to that point, 860 kilometers, and that was the point when it was exactly 1000 kilometers from R. So now from there, now getting the time taken, because for us to find the time, it was there, we need to find the time taken from S to that point. So time taken is given by, so time be given by distance divided by the speed. And we have the distance, we got the distance as AC and 860 kilometers, then the speed was 400 kilometers per hour. So this will give the time in hours. When you divide this, you will get 2.15 hours. And when you convert these, to hours, and it's the same as 2 and 3 over 20 hours, which is equivalent to 2 hours and 9 minutes. 2 hours and 9 minutes. So it left S at 8 a.m. and then that distance took 2 hours and 9 minutes. So it was the time when aircraft exactly at this point. Therefore, it was exactly 1000 kilometers from R at 10:09 a.m. The following figure represents a piece of land in the shape of a trapezium ABCD. Lines AB and DC are parallel. Point M is the midpoint of AB. The land is divided into 3 triangular plots. Line AB is equals to 100 meters. AD is equals to 39 meters, MD is equals to 41 meters, and angle ABC is equals to 30. So you can see the figure there. Part A, calculate the area of the triangular plot AMD and hence the perpendicular distance between the 2 parallel lines. So you're supposed to get the area of this plot AMD. So AMD. So we have M as the midpoint. So M is the midpoint of AB. So that means if AB is 100 meters and M is the midpoint of that line, so that means this one is 50 meters and this one is 50 meters. So look at AMD. That one is a triangle whereby you have all the 3 sides given. So which particular formula do you need to use when you have a triangle and all the sides, the 3 sides are given, the lengths are given? The hero's formula is the best in this case. So the hero's formula, let me state the hero's formula. State area is equals to S minus A, S minus B, S minus C, and then you get the square root of that, where A can let this one to be, can let A to be 39, then B, we can let B to be this one, and then you can let C to be that. I think that one will be okay. Now we can replace this. The first thing is to get S. S is given by A plus B plus C divided by 2. In this case, it will be 39 plus B is 41 plus 50 divided by 2. And this will give 65. So that is S. So now get the area S, which is 65. Then S 65 minus A 39, then 65 minus b, that is 41, then 65 minus c, c is 50, like that, and then you get the square root of that. So this will give 65 times 65 minus 39, that will give 26, times 65 minus 41, that will give 24, then times the other one, 65 minus 50, you give 15, and then you get the square root of that. So when you get the product of these, you shall get this one as 608,400. That is what you get. And when you get the square root of that, you will get 780 meters squared. That is the area using the hero's formula. There are two questions in that part. So we got the area of the triangular plot AMD. Now we need to get the perpendicular distance between the parallel lines. So the perpendicular distance is this distance here. It can either be this one or it can be this one that is here. So you can use either. So we need to get this distance, this perpendicular distance here. We can call this one the height. We can call it the height. So to get that, since we have the area of that AMD, look at this height that I've put there. Let me put this as n. So look at the height dn. The height dn, that perpendicular height, is the height of that triangle that you have already obtained the area AMD. So using the other formula, because since you have the area of that triangle, using the other formula, area is equals to a half base times height, and in this case the height will be that height, that is a dn, that is the required height, perpendicular height between the two parallel lines. So we have the area as 780, so we can say that half times the base in this case is am is the base, which is 50, times the perpendicular height, that is what you are looking for. That one should give us the area of that triangle, 780. So this will give 25h is equals to 780, and h, divide both sides by 25. This will give 31.2 meters. That is the perpendicular height. So we're through with that part. Part B, calculate the length of 1 BC. The length of BC. The length of BC. Now to get the length of BC, I'd like you to consider, look at that triangle. I can name this one. There's a height here. I drew the height here, and maybe you can call this point. You can call this point O. Look at triangle COB. COB. So look at that triangle COB. COB. When you look at that triangle, we can, since we have that angle 30 degrees at B, we can use trigonometric ratios to get the length BC. And this is how we're going to do it. Since we have that height, we already have the perpendicular height between the two parallel lines. Remember that CO is equivalent to DN that we have already obtained. So I can extract that triangle here. So this is B, and then we have O and we have C. We have O there, we have C there. So the height is 31.2. So we need BC, and then we have this angle here as 30 degrees. So look at what I've extracted there. So having these, it is possible to use trig ratios to get BC. So I can use sine Sine is the best one to use. Sine of 30 degrees is equals to the opposite side divided by the hypotenuse. The hypotenuse is the required side. So make BC the subject, and so BC will be given by that 1.2 divided by sine 30, and these will give BC as 62.4 meters. So that is BC. The next one is MC. MC is the next. We need to get MC. So since we have BC, this one is 62.4. Now we need to get MC. So for that one, we are going to consider triangle BMC. Triangle BMC. So look at triangle BMC, and I will extract it here. BMC is there. So let me extract it. BMC, like that. So we have BC is 62.4, and then BM is 50, so that one is 50. So BM is 50, and then we have this angle as 30 degrees. So we need to get MC. So when you look at that triangle, the best method to use, think of how you're going to solve that and get MC. You can use the cosine rule. Easily. Cosine rule will help because we have two sides and an included angle. So we can name this side opposite B. This one is B, then this side M, then this side C. So using this the cosine rule, that B squared, remember B is MC, is equals to M squared plus C squared minus 2MC cosine of B. So if we substitute everything there, you notice that it will help us to get CM. CM in this case is B. So therefore B squared is equals to M squared. This is 62.4 squared plus C squared 50 squared minus 2 times 62.4 times 50 multiplied by cosine of B, which is 30 degrees. So this stage you can simply feed everything in the calculator here on the right hand side, and when you do that, just to simplify the workings here, you get 989.8. that is B squared. So we need B, not B squared. So B will therefore be given by the square root of 989.8, and this one will give B as 31.46 meters. Remember, B is what you're looking at, that is MC. So that is MC. So MC is 31.46 meters. Part C, calculate the size of obtuse angle BMC. Obtuse angle BMC. What is an obtuse angle? An obtuse angle is an angle that is greater than 90 degrees but less than 180. So the obtuse BMC, we identify that one in this diagram, is actually this angle that is here. This is the angle BMC, that is the angle. So what we need to do, if we use this triangle here, let me extract this. So OMC. So if I get this angle that is here, if I get angle OMC, that will simply help me get the obtuse angle BMC. So let me begin by getting this angle here, OMC. And what am I going to use? Trig ratios. I have the height, I have CM. So I have the height. Remember the height, we got the height as 31.2. So this is the height, 31.2. And then we have the other one, which is a CM. We got CM here is OMC, 31.46. We got this one as 31.46. So it is possible to get that angle that is there. So once I get that angle, I'll simply take 180, then subtract that angle in order to get angle BMC. So I can use sine. So sine of theta is equals to opposite, that 1.2 divided by, so that 1.2 divided by 31.46. So simply get to get theta, this angle, you simply need to get the sine inverse of that 1.2 divided by that 1.46, and this will give, use a calculator, this one will give 82.63 degrees. So what we have already obtained is this angle that is here, 82. So we have this angle, this is what you have obtained as 82.63. So definitely, because that is a straight line, to get now angle BMC, so angle BMC, we are simply going to take 180, and then we subtract the angle on the left hand side, that is angle OMC, 82.63 degrees, and that will give us the obtuse angle as 97.37 degrees. Two matrices P and Q are such that P is equals to 37H4 and Q 53, -4, -2. The determinant of PQ is equals to 3. Part A, 1. Determine the value of H. Determine the value of H. Now you already given the determinant of this matrix PQ, and you have matrix P and Q. So you need to get the product. PQ means you get the product of matrix P and Q. So you multiply them. So let's get the product. So you have P is 3H, then we have 7, 4, that is P, multiplied by Q. Q is 5, 3, -4, -2. That is the product PQ. So we get this product. So kindly ensure before you solve this question, you are familiar and conversant with the way you're supposed to multiply a 2 by 2 matrix, how you multiply the rows and the columns. So you have, for example, the first row, the first column. These matrices are compatible. For the first element here, you get 36, and then the first row, the second column there, 3 times -4 plus 7 times -2, you get -26. Then we go to the second row, first column, 5 times H, that is 5H plus 4 times 3. So this will give 5H plus 12. And the last element, H times -4, that is -4H. -4H subtract 8. So that is the product PQ. So this is PQ. Now you given that the determinant of that matrix, that product, is 3. So you know how you get the determinant of 2 by 2 matrix. So the determinant, you get the product of these diagonal. So determinant, that is 36 multiplied by -4 4h, subtract 8, then subtract the product of the other diagonal here, that is negative 26. Negative 26 multiplied by 5h plus 12, like that. So this one will give 3. That is how we get the determinant. So we saw 4h. So 4h, so open the brackets here, you get this is negative 144. H, subtract the 6 times 8, you get 288. Then subtract, this is negative 26, this will give negative 130. H, then this one will give negative 312 is equals to 3. Continue. So this is negative 144h, subtract 288, then open the bracket here, you get 130h plus, you need to be very careful when opening the bracket. These negatives, when you multiply them, they will give you positive. 312 is equals to 3. So like terms together, so you have negative 144h plus 130h, that will give negative 14h. Negative 14h, then negative 288 plus 312, that will give positive 24 is equals to 3. So when you work out h here, you'll get h as this will give negative to be positive, because you get negative 21 divided by 14. So h will give 3/2, but you simplify this and leave it as 1.5. So h is 1.5. Part 2, find the inverse of p inverse. That is the inverse of p raised to power negative 1. So let's go to p. The matrix P is here. 3h, h is 1.5, we already got that. And then we have 7, 4. So we need to get the inverse of this matrix. Just to remind us, if you have a general matrix, let's say A, B, C, D, 2 by 2 matrix, how do you get the inverse? The inverse of this kind of a matrix is given by 1 divided by the determinant of that matrix, and then you know how you're supposed to interchange these values. So you have D minus B, then minus C, A. So look at the way these are diagonals. So the elements in these diagonal here, they are interchanged, these, and then for the other diagonal, they actually change the signs. So this is what is going to guide us. In case you have any 2 by 2 matrix, that is how you get the inverse. So we start by getting the determinant. So we get the determinant of this matrix, we get the product of this diagonal. This is 3 multiplied by 4, subtract product of these 7 times 1.5. So this will give the determinant to be 12, subtract 10.5, and this will give 1.5. That will give 1.5. So that is the determinant. So now the inverse of P, will be given by 1 divided by the determinant. And then look at the way we change the elements here for A, B, C, D. So these will be 7, negative 4. No, not 7, negative 4, sorry. So just change the elements there. Look at A, B, C. So, and look how we did it. So this one will be 4, -7, like that. Then -1.5, -1.5, 3. We're being guided by whatever I gave you there. If you have a matrix A, B, C, D, how do you get the inverse of that? So now everything that is inside this bracket here should be multiplied by 1 divided by 1.5. So multiply each element by that. Each element that is there, that is 4, -1.5, -7, 3, multiplied by 1 divided by 1.5. And when you do that, 1 over 1.5 times 4, that will give 8 over 3, because you can change these 1.5 to be 3 over 2. Then 1 over 1.5 times -7, that will give -14 over 3. Then 1 over 1.5 times -1.5, that will give -1. And then 1 over 1.5 times 3, that will give 2. That is the inverse. Part B. Patel and Lagat purchased watches at M shillings per watch and N shillings per phone. Patel purchased 12 watches and 28 phones for 24,600. Lagat purchased 15 watches and 40 phones for 34,500. 1. Form 2 equations in M and N. So we start with Patel. Patel, 12 watches. Patel 12 watches, each at M shillings. So that will be 12M, like that, 12M. And then we proceed to the other one, 28 phones. That will be 28 multiplied by each of them cost N shillings, and this one gives a total of 24,600. That is the first equation. Then you go to Lagat. Lagat purchased 15 watches, so that will be 15M, the cost of all the watches. Then and 40 phones, each at N shillings, and the total is 34,500. Those are the two equations. Those are the two equations. Now what you can do, you can decide to simplify these equations so that you may have an easy time when you are working out. So if you simplify these, the first one there, and you decide to divide everything by 4, divide everything by 4, every term by 4, you'll get this one to be 3M plus 7N is equals to 6150. That is when you divide all through by 4. The second one, you can divide all through by 5. Divide everything by 5 for the second one, and this one will give divide each term by 5. This will give 3M plus 8N is equals to 6900. So you can leave the equations in that form, simplified form. Part 2, use the matrix method to determine the price of a watch and that of a phone. The matrix method. So for the matrix method, first of all, we'll use the simplified one. Use this one. So we extract the coefficients of M and N. Kindly ensure that you have arranged them in this order. You have M, the coefficient of M, we have 3, 3, then for N, 7, 8, then M and N, what you're multiplying with, is equals to, this is what you are using here. This will give 6150, 6900, like that. So this is what you're supposed to solve using the matrix method. So the first thing is to get the inverse of this matrix, 3738. 3738. That is what you're supposed to get the inverse. So we start by getting the determinant. So you're getting the determinant of this matrix here. The determinant of that matrix is 3 multiplied by 8 subtract 7 multiplied by 3, and these will give 24 subtract 21, that will give 3. So we get the inverse. The inverse of that matrix is 1 divided by the determinant, and then remember what we did in the previous part for the general matrix A, B, C, D. When you're getting the inverse, 1 of the determinant, then look at how we interchange the elements in both the diagonals, the leading diagonal and the other diagonal. Look at what happens there. So that is what is going to guide us there. So when you interchange these values, this is what you're going to have. So you have 8, negative 7, and then negative 3, 3. So that will be the inverse. So you can leave it like that, or you can multiply each element by that, in the bracket by that. So after getting the inverse, you pre-multiply both sides of the equation by that inverse. So we go to the left hand side, so we have the inverse is there. So this is 3, not 3, the inverse is 8, negative 3, negative 7, 3. We have 3, 3, 7, 8. We have MN. So that is the left hand side. So you can see this is the inverse. You are pre-multiplying both sides with that, is equals to the right hand side. We do the same. That 8, negative 3, negative 7, 3 of 6150, 6900, like that. So on this side again we have, that is the inverse. So that is what we mean by pre-multiplying both sides of the equation by the inverse. Now you notice that on the left hand side, on this side, when you multiply out everything here, you'll get an identity matrix. You get 1, 0, 0, 1. That is what you get. Then for the right hand side, you can multiply these two, 8, negative 3, negative 7, 3. So let me multiply that. So you shall have row 1 times that column. So you have 8 multiplied by 6150, 8 multiplied by 6150 plus negative 7 times 6900. That is the first row. The second row shall have negative 3 times 6150 plus 3 times 6900, like that. So this one will give a third. Use a calculator. The first row you'll get, use a calculator to do that, you'll get 900. Then the second row, negative 3 times 6150 plus 3 times 6900, that will give 2250. 2250. Then from here, a third multiplied by 900, you get 300. A third times 2250, you get 750. So that means now you have on this side 1001. When you multiply anything by the identity matrix, you're multiplying MN by the identity matrix. Identity matrix does not change anything. It's just the same way as multiplying by 1. So on that side you shall have MN, the left hand side, is equals to, so you have 300, you have 750, And now from here you have the solution. You have the solution because m therefore will be 300 and n will be 750. The question is price of a watch and that of a phone. Remember, m was the price of the watch, so this m was the price for the watch. So watch, that is m, is equals to 300, and then the phone, which is n, the price is 750. Members of environmental club planted trees. The number of trees planted by each member is recorded below, as you can see. Part 1, using a class width of 5 and starting with the class 6 to 10, make a frequency distribution table for the data. So you're supposed to make a frequency distribution table starting with the class I. So prepare a table here. So number of trees and frequency. So we have a number of trees and then frequency. We prepare a table here, and then we have the frequency. So beginning with class size is a class of 6 to 10. So the next one will begin from 11 to 15, then the other one 16 to 20, then the other one 21 to 25, then the next is 26 to 30. Remember, we're maintaining the class size of 5. And then when I look at the largest figure here, just by looking at it, I can see we have 33. 33 is the largest, so we can go up to, yeah, I think that one is, I don't see any that is above 33, so we can go up to 35. So the last one, 31 to 35. So this is how you do it. So the frequency like that. So now let's go to 6 to 10. 6 to 10, we count any value or figure that is in between there, we look for that. So 6 to 10, so you have 1 there. 6 to 10, we have another one here. 6 to 10, any that is between there, 6 to 10, you can see we have 6 to 10, 6 to 10. Let me see, 1 2 3 4 5 6 7. Oh, there's one that I'm missing. Let me see, let me just confirm. So 6 to 10, 6 to 10, yeah, I have one here. So I've circled all of them that are in that range, 6 to 10. So 1 2 3 4 5 6 7 8 9, they are 9. Then 11 to 15, any value that is in that range, 11 to 15. So 11 to 15, I have one there. 11 to 15, 11 to 15, 11 to 15. I'm identifying all of them. 11 to 15, 11 to 15, 11 to 15. So we have confirm whether I've circled all of them. So all of them are there. So let me count them in red. 1 2 3 4 5 6 7 8. There are 8. Then 16 to 20, 16 to 20, any value that is between 16 to 20, 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 16 to 20. Let me count how many they are. (16 to 20). Yeah, I think I've identified all of them in green. 1, 2. So have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10. There are 10. Then 21 to 25. 21 to 25. 21 to 25 have one there. 21 to 25. 21 to 25. 21 to 25. So let me count them. 1, 2, 3, 4, 5, 6. There's 6. There's 6. Then 26 to 30. 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 26, I can't see one there. 26 to 30, another one is there. Another one is there. 26 to 30. Yeah, they're not many. There are only 3. I've identified 3 only. And then we have that 1 to 35. That 1 to 35. Now that 1 to 35, we have 1 there. That is 1. And then we have 2. 2. And then we have 3. You see, we have, let me count again. That 1 to 35, we have 1 there. We have 2 here. We have 3, and we have 4. There are 4. So you can involve the tally as well. You can involve the tally. The tally. So you have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have 1, 2, 3, 4, 5, 6, 7, 8. Then for 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 1, 2, 3. Then 1, 2, 3, 4. So that is the complete frequency distribution table for the data. State the model class. The model class, that is part 2. The model class is the class with the highest frequency, and that is 16 to 20. 16 to 20 is the model class. Part 3, estimate the mean number of trees planted, the mean. Now to calculate the mean, I'll simply arrange these, organize it in form of a table for easier working. That, so we have the classes. The classes, so we have 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30, 31 to 35. Then the frequency, we have 9, 8, 10, 6, 3, and 4. That is the frequency. Now to get the mean, this is the formula that you're going to use to get the mean. So mean is given by the summation of fx divided by summation of f. So you need to get x first. X is the midpoint of these classes. So the midpoint of 6 to 10. So you simply add 6 plus 10 divided by 2, that is 8. That would be 8. The midpoint of that class. The other class, 11 to 15, simply get the x, the midpoint, by adding 11 plus 15, that is 26. 26 divided by 2, 13. And since the classes are, the class size is uniform, it is 5. So from 8 you can see 8 plus 5, 13. 13 plus 5 I go to 18. 18 plus 5, 23. 23 plus 5, 28. 28 plus 5, 33. Then now you can get the product fx. So 9 times 8, 72. 8 times 13, we have 104. Then this is 10. This was 10 times 10 times this one 180. Then 6 times 23, 138. Then 3 times 28, you get 84. Then 33 times 4, 33 times 4, you get 132. So that is what you're supposed to have. Then from there, you sum up everything from 72, you add everything up to 132. So mean therefore is given by the summation of fx, which is summation of fx, add everything here. So 72 plus 104 plus 180 plus 138 plus 84 plus 132, that will give 710. Give 710, divide by the summation of frequency. Frequency, you add everything, this column, frequency 9 up to 4. 9 plus 8 plus 10 plus 6 plus 3 plus 4, and that will give 40. So when you work out these, you will get 17.75 as the mean. The other part B, on the grid provided and on the same axis, represent the data using 1, a histogram, then a frequency polygon. So let's start with the histogram. So how do you draw a histogram? You simply plot the class boundaries against not the class boundaries, but the frequency against the class boundaries. So on the y-axis, you should have the frequency. Then on the x-axis, have the boundaries of these classes. So me look at these frequencies. So the frequency, I can use a scale of 1 centimeter represents 2. That one will be okay. That one is going to work. That one is going to work. So shall have 0 there. Then this one is the y-axis. So I shall have 2, 4, 6, 8, 10, 12. Let me see the highest. The highest frequency is 10. So that one is okay. Then for the, so this is the frequency. The frequency which represents in this case the number of these are the number of trees. So these are the number of trees. Then we have on the x-axis, the class boundary is there. So we have the lowest is 6 to 10. So we can start with a slightly lower class. The boundary, the lowest class boundary of 6 to 10 is 5.5. So we can decide to start a little bit lower for that class, that is 0.5, so that we can have a scale of 5. The scale of 5, 1 centimeter represents 5. So we can start with 0.5 and can start with that here, 0.5 there, and then from there we can add 5.5. Then the next one will be 10.5, then 15.5, 20.5, 25.5, then 30.5, 35.5, and since it doesn't go beyond that, we can start the same way we started on a slightly lower class. We can extend a little bit for the purposes of the frequency polygon, so we can go up to 40.5. So when you look at 0 to 0.5, that is the only place we don't have uniform scale. Otherwise, from 0.5 all the way to 40.5, the scale is uniform. So to show that this scale from 0 to 0.5 is not uniform, you can break it like that. Now from there we can plot. So the first class is 6 to 10. 6 to 10, the frequency is 9. The frequency is 9. 6 to 10. 6 to 10 starts from 5.5, that is the lower class boundary, to 10.5. So that one is 9. 9 is in the middle, exactly the middle of 8 and 10. 8 and 10, exactly there. So from 5.5 move up to this somewhere there, exactly at the middle of that. Then you draw it like that. So that is the first one. Let me shade it so that you can be able to see that one properly. Then the other one is from 11 to 15. That one is 8. 11 to 15, so it starts from 10.5. that is the lower class boundary of the second class. 10.5 to 15.5. that one goes up to 8. So it goes up to 8 like that. So again, shade that one so that you can see it properly. Then the next one is 10. 16 to 20. 16 to 20. So 16 to 20, frequency is 10. Frequency is 10. So 16 to 20, it starts from the lower boundary of 15.5 20.5. So the frequency there is 10. So it goes up to 10 there. Sorry, it goes up to this point. So up to 10. So like that. And then I can shade it like that so that you can see it properly. Then the next one is 20.5 to 25. The other class is 21 to 25. 21 to 25. So 21 to 25 starts from the lower class boundary is 20.5. The upper one is 25.5. That one, the frequency is 6. The frequency is 6. So we go up to 6. Again, can shade that on like that. The next class is 26 to 33. 26 to 33. 26 to 30. So 3 is between 2 and 4. Between 2 and 4. So somewhere there. So somewhere there. 3 is there. So you can shade that as well. And then the last one. Is that 1 to 35. The frequency is 4. The frequency is 4 there. So the frequency is 4. So there it is. So there it is. So shade it like that. So that is the histogram. We've done the histogram. Now the next one is the frequency polygon. The frequency polygon. So for the frequency polygon, we join the midpoint of the top of these bars. The midpoint of the top of the bars using straight lines. So for example, look at the first bar. So you draw a straight line joining the midpoint, the top of each bar. Look at the top of each bar, then look at the midpoint of the top of these bars. So you join them using a straight line like this. So straight line moving like this, joining the midpoints of the top of these bars like that. So that is what you're supposed to do. So let me draw the line. So so the first one starts from here, and then that point, then straight line, use a ruler for this, that point, and then from there that point, and then from there that point again. Sorry. Like that. Like that. And then I've joined on each bar, the top of each bar. Look at them. I'm joining the midpoints. The midpoint of that bar to the midpoint of this bar, the midpoint of this bar to the midpoint of this bar, the midpoint of this bar there. So to ensure that this bar is not hanging, and that is why we started with a slightly lower class, you join it directly to this point here. Ensure that it is not hanging to this bar that you introduced. Remember, we started slightly on the lower one, 0.5 to 5.5, and then we extended a little bit, 35.5 to 40.5, to ensure that these bars are not hanging. So from this point you join it like that. So using a straight line, use a ruler for this, and that is exactly how you're supposed to draw the histogram and the frequency polygon. On the Cartesian plane below, triangle ABC has vertices A -4, -4, B -2.57, and C -2, -5.5, while triangle A triple prime, B triple prime, C triple prime has vertices 1, 2, 4, 8, and 5, 5. That is for A and C images. The line joining A double prime 2 -1, B double prime 8 -4 is part of another triangle A double prime, B double prime, C double prime. So you can see it is here. So the diagram is here. So you can see the figure, it is here. So let's go to the first question. So the first question, that is part A. Triangle A prime, B prime, C prime is the image of triangle ABC under an enlargement, center -3, -2, and scale factor -2. On the same grid, draw triangle A prime, B prime, C prime. So from the diagram you can see ABC, triangle ABC. We're given that A prime, B prime, C prime is the image of that triangle. Under enlargement, center is given -3, -2. So let us first locate the center. -3, -2, -3, -2 is here. That is the center. So let me mark the center. So I'll mark the center here. So name it C. So that is the center. And then we need to enlarge triangle ABC with that center and scale factor -2. So this is how we're going to do it. We shall start by joining point A to the center of enlargement using a straight line. Point A, the center of enlargement, using a straight line. We do that. So using a straight line, we have from point A, make sure you use a straight line like that. And then we need now to locate A prime, and we'll be guided by the scale factor. The scale factor is -2. So -2 means that we're going to enlarge this triangle twice. Negative scale factor of enlargement implies that the object and the image will be on the opposite sides of the center of enlargement. So this is what you're going to do. We are going to simply take the distance A to the center. Take that distance A to the center. This distance from A to the center of enlargement, that distance. That is what we're going to do. So look at this distance from A to the center of enlargement. Now because we are enlarging by 2, we need to double that distance. And now we are going to calculate now from this point C, we double that distance. So look at this. This is me read this. So from this point from A to where C is, and C is around 2 point, that is around 2.7. So 2.7. So when we double that distance, this is what you're supposed to do. You can do this using a pair of compass to still work. So you take this distance A to the center of enlargement, then from now C, you measure double that distance. So AC, take that distance AC, and then from C, measure double that distance AC. So double distance AC. Now from, you can see this one is around 2 point. So from A to this point here, you can see this one is around 2.7. So now from now C, double that distance 2.7, you're going to have something to do with 5.4. So I will indicate it here so that you can see, just to illustrate the first one. So from A to C, that was I've measured 2.7. So because you're enlarging by -2, now from C to where A will be located, A prime will be located, we're going to double that distance. So 2.7 times 2. So from here now, we're going to measure, so from this point we measure double that distance, 5.4. So 5.4 will be here, to be exactly here, 5.4. So you mark. So this will be the point. So it will be here, to be exactly here. So this is where we shall have A prime located. So this distance will be 5.4. Alternatively, you can use a pair of compass to do that, or you can measure using a ruler to still be okay. So that, you can see that is -2. That is enlargement by -2. I've just said that the negative scale factor of enlargement simply implies that the object and the image will be on the opposite sides of the center of enlargement, as you can see. So we have A here, you can see, and then you have A prime here. You can see the center of enlargement is here. You can see both of them are on the opposite side, that is A and A prime. So that is what you're going to do for the others. Going to do the same for the others. So for B, you'll simply join B to the center of enlargement. Join B to the center of enlargement. So B is here. So join it to the center of enlargement like that, using a straight line like that. Yeah, join it like that. And then take that distance from B to C. So from B to the center of enlargement, take that distance and then double that distance, and now measure this distance from here all the way to that. So let me use a ruler for that. So I'm measuring from B to the center of enlargement, that one is around mine is around 6.1. So that distance is around 6.1. So when I double that distance, 6.1, I'll get 6.1 times 2. I'll get this one as 12.2. So now from C, you're going to measure 12.2. So we've measured this distance here. I'm just indicating it so that you can see. So from B to C, that is 6.1. So you multiply that by 2, so double that distance will be 12.2. So from C now, measure 12.2, and that is where B prime will be located. So it will be around here, to be here. So this is where we are going to have to be here, at this point. So B prime will be there. So this is 6.1, and then this one will be 12.2, double that distance. So this will be the position of B prime. So for C, do the same for C. Join C to the center of enlargement. That you need to be very keen when you're joining. Use a ruler to do this solve. That is the thing. Then measure the distance C. Let me do this one again. I think it is not very clear. So from C to the center of enlargement, yeah, that one is okay. You can see that one is okay. It's okay. So now from C, take this distance from C to the center of enlargement, take that distance, and then you double that distance. So let me take that distance from C to the center of enlargement. You can see this is around 4 point. That is around 4.4. So 4.4. Double that distance. That will be so 4.4. In my case, 4.4. So multiply by 2, that will be 8.8. So I'll need now to measure from C. So from C, I have to measure 8.8. So 8.8 will be here. 8.8 will be there. So let me mark. It will be exactly here. To be exactly there, 8.8. So it will be here, 8.8. Noted, it will be here. So let me mark it here. So that is how we shall have C prime, like that. Now we have the positions of A prime. A prime is here, A prime is here, B prime is here, and C prime is here. Now join those points to make that triangle using straight lines. So join them. Let me use a different color for these. Like that. that. And there you have the complete triangle. So the question was, on the same grid, draw triangle A prime, B prime, C prime. We've done that. It is there. So the other question, part B, triangle A double prime, B double prime, C double prime is the image of triangle A prime, B prime, C prime under rotation. Center 0, 0. The first question, state the angle of rotation. The second question, complete triangle A double prime, B double prime, C double prime. So let's look at those triangles. So triangle A double prime is here. So let me get rid of these. So A double prime is here. So it is not complete. It is the one that actually you can see it is only, we're only having 2 points, that one and that one. So this one is the image of this triangle here that we've just obtained. So the center of rotation is given. So we need to get the center. The first question, we need to get the angle of rotation. So this is how you get the angle of rotation. You just need to join one point. I'll join A prime, or join A prime to A double prime using a straight line. And I'll join that through the center. So join A prime to the center first. So I'll join this point. Let me explain this. So A to the center, which is the origin. Join that. So join it like that. And then from the center to A double prime. So that is how you identify the angle of rotation. So I've joined A prime to the center of rotation, then from the center to A double prime. Then from there, remember that A prime is the one that is being mapped onto A double prime, and therefore when you're measuring the angle, you need to measure the angle from A prime to A double prime through the center. So this is how you get the angle. You simply take your protractor, and this is how you're going to place it. So make sure the center of that protractor is at the center, is at that origin, 0, 0, like that. Ensure that this line, that part of the protractor lies on straight line, on this straight line, then the center is there. So now we're going to measure this angle from this point A, moving like this to A double prime. That is how we're going to measure it. So just read this angle. So we're measuring it from here. So this is 0, 10, 20, like that. On 20 we have 130, 140, and then we have this is the here. So we can see this one will be 144. Mine is giving 144. So this is 140, this is 144. So from here you measure it like this. So this is 10, 20, like this. So, and you can see the movement is clockwise. The movement is clockwise. So that is 144 in a clockwise direction. That is the angle. So this is how you're supposed to write the angle. So 144 degrees in a clockwise direction. So if you move this word here clockwise, you can also write it as negative 144 degrees. It still means the same thing, that This negative implies that it is in the clockwise direction. Then you're supposed to complete, that is part 2, complete triangle A double prime, B double prime, C double prime. Complete that triangle. So the only place, the only point that you don't have is point C. We have A double prime, B double prime, so we need to identify C double prime. So the same way we're going to do, because the points are being rotated through the origin, the angle of rotation is 144. We simply join C prime to the center of rotation. That is the first thing. So we join C to the center of rotation like that. So we've joined that. So we've joined C to the center of rotation, and then I place the protractor along this line I've drawn. Be very keen when you're placing it. So ensure that the central part of the protractor is at the origin, then place it like that. So you can see I've placed the protractor on this line drawn. You can see then the center is there. So now we measure 144 degrees in clockwise direction. In a clockwise direction, 144 will be 144 will be here, to be here. Let me see, 144 will be somewhere here. So we draw a straight line. We draw a straight line from this point. So from the center, so 144 is there. So you can see, and that is I've drawn a line where we have 144. So 144 is measuring from here. So look at this is 140, so 144 is here. So from here you've measured from 0 all the way to 144, then you draw a straight line. So that angle, you can mark it. So this angle, this is the angle that you've measured. This is the angle that you've measured, 144 degrees. So after measuring the angle and having drawn the line, now this is how you identify point C. Take this distance that is here, distance C prime. You can use a pair of compass to do this. Use a pair of compass to do this. Take that distance. So from C prime to the center, so from C prime to the center, take that distance. So from this C prime to the center, that distance should be equal from C, from the center to C double prime. So you mark an arc there. So this is where now we shall have C double prime. So this distance is what you've taken, this distance from C prime to the center, and then transfer that distance from the center to where now C double prime will be. Used a pair of compass to do that. So that is the distance, you can see, from C prime to C double prime standing at the center. Now we have identified the point C where it will be. Now we can complete these this particular triangle by joining the vertices. So B, we have B prime to C, and then from this point C to A, and there we have the triangle. So A double prime, B double prime, C double prime. We've completed that. Now from there we go to the next question. So we've completed that. Now we can go to part C of the question. Now part C of the question, there is some corrections. There was a mistake in typing or typing error in the questions, so I've corrected it there. So triangle A double prime, B double prime, C double prime is the image of triangle A triple prime, B triple prime, C triple prime under a reflection. So draw the mirror line. We start with that. Draw the mirror line. So A double prime is the image of A triple prime. So let us identify those triangles. So they're here. So these it is this triangle and this one. So given that this is the image of this, so this is the image, this is the image. Let me write it here. So this is the image and this one is the object. So it is a reflection, so we need to get actually get the line of reflection, the mirror line. Draw the mirror line. So the mirror line is a line that actually passes through the center of the two figures, that is the image and the object. You need to remind yourself of the properties of reflection. So this is how you're going to do. You can use any 2 points. For example, I will use a point. I'll use point C double prime and C triple prime. So you can join any. You can use A double prime and A triple prime, still the same. You can do it for B if you wish. You can do for C. You can join C. So I'm just choosing. I'm just choosing. So this is C double prime, C triple prime. So I'll choose these. Instead I'll join C double prime to C triple prime, and then after you join, now remember the property of reflection. The object and the image are supposed to be equidistant. So here we have the object as C double prime, the image as C triple prime. Those points are supposed to be equidistant. So, and that is where we shall now draw the mirror line. The mirror line should be exactly between those 2 points. The mirror line should be exactly between the 2 points, that is C double prime and C triple prime, because of the properties of the reflection. The image and the object are supposed to be equidistant from the mirror line. Supposed to be equidistant from the mirror line. So, and therefore, to do this, I'll simply take a pair of compass. And you know how to construct a perpendicular bisector or bisector of this line, C double prime, C triple prime. So standing at C, I simply open pair of compass more than a half, and then standing in that point, so you can mark an arc, and then on the other side, you mark an arc with the same radius, though changing. Stand on the other point, C triple prime, and then cut this arc, and then cut the other arc, like that. Then from there, simply join the point of intersection of the arcs. So join. That. So now join. Draw it like that. So that is the mirror line. So use the properties of reflection, that the object and the image are supposed to be equidistant from. Supposed to be equidistant. Let me check whether I've drawn it in the right way. Have I drawn it in the right way? I think there is a slight error. The way I've joined, let me join it again. Need to be very keen when you're joining. Then check the point of intersection. Point of intersection. Yeah, let me see. Yeah, I think now that one is okay. Yeah, it is okay. It is passing through the point of intersection of the arcs. So that is the mirror line. So that is the mirror line. So as you can see, these points are equidistant. So this distance here is the same with this distance. So the object and the image are equidistant from the mirror line. That is a very important property of refraction. Now after that, the next question is determine the equation of the mirror line in the form y is equals to mx plus c. Now that is the equation of a straight line. The mirror line is simply a straight line, and you need to just get the equation of that line. So I will use any 2 points. So to get the equation of that mirror line, because it's a straight line, you simply need to identify any 2 points on that line, any 2 points. Let me check to see whether I may get. So I have this point 9 and 3. I can have this point, and then I have 6 and 2. 6 and 2. So 6 and 2, I can take these 9, 3 and 6, 2 to get the equation. Any 2 points on that line. So 9. So I've taken 9, 9, 3 and 6, 2. 9, 3 and 6, 2. So having those 2 points on that line, you can get the equation of the line. Start by getting the gradient. Gradient is change in y divided by the change in x. And this will give -1 divided by -3. So the gradient will be a third. So the gradient is a third. So if the gradient is a third, you can now use any 1 point here. Several ways of getting the equation in the form y is equals to mx plus c. I'll use this method. I'll just take one of these points, either 9, 3 or 6, 2, and another general point xy on that line. So using these 2 points, I can get the gradient which I have here. So how do you get the gradient? Change in y. So y subtract 2 divided by the change in x. X subtract 6 is equals to the gradient. Then from here you can simply cross multiply. So you have 3 y subtract 2 is equals to x subtract 6. So this will give 3y subtract 6 is equals to x subtract 6. So 3y is equals to x plus 0, and therefore y is equals to a third x. That is the equation of the mirror line in the form y is equals to mx plus c. Then part D, I also did some corrections. There were some typing errors. So describe fully a single transformation that maps triangle A prime, B prime, C prime onto triangle A triple prime, B triple prime, C triple prime. So it is the first triangle. So let me identify those triangles. So you have this triangle here. Is it this one and this one? Look at them. This one. Which transformation maps this triangle to this? This triangle to this? By just looking at it, just look at the points. The points will help you to know. Look at B prime, look at B triple prime, look at C prime, C triple prime, look at A prime, look at A triple prime. So you can simply take the points. I will just take one to know the transformation. Like for B prime is -4, 8. So B prime is -4, 8, and that one is mapped onto B triple prime, that is 4, 8, 4, 8, 4, 8. So look at the points. The x coordinate, look at the x coordinate. The x coordinate changes the sign, but the y coordinate remains the same. So which transformation has that property? That is simply a reflection along the y-axis. So in this case, the y-axis is acting as the mirror line. It is acting as the mirror line. And you can see we say the property of reflection is that the object and the image are equidistant from the mirror line. So y-axis being the mirror line, you can see this distance from the mirror line to B triple prime is the same with this distance here from the mirror line to B prime. So that is simply a reflection. It is a reflection along the y-axis. The gradient of the curve y is equals to x cubed plus 5x squared plus px minus 18 at x is equals to -1 is -15. Part A, find the value of p. Find the value of p. So you're given the gradient of this curve at this point at x is equals to 1 is -15. So the first thing you're going to do is to get the gradient function of this curve. The gradient function, you get it by differentiating this function y with respect to x. That is the gradient function. So differentiate each term. X cubed, when you differentiate that, you get 3x squared. Differentiate 5x squared with respect to x, you get plus 10x. And then differentiate px with respect to x, that will give positive p at that point. -18 is a constant. So that is the gradient function, and that is what is going to give us the gradient. So it means that at this point x is equals to -1. That means when you substitute -1, x is equals to -1 in this expression, we should get 15. So you do that. So 3x squared, x is -1 squared, plus 10, x is -1, then plus p. These will give us the gradient, which is -15. So these will give 3, then subtract, this is 10 plus p is equals to -15. So these will give -7 plus p is equals to -15. So p is equals to -15 plus 7, that will give -8. So that is the value of p. Part 2, the equation of the normal to the tangent to the curve at x is equals to -1. The equation of the normal to the tangent. Now one thing that you're supposed to understand is that the normal is perpendicular to the tangent, so the normal is perpendicular to the tangent. And that means since we have the gradient of the tangent, it is obtained by getting this. Look at this, we are given it here. The gradient of the curve at x is equals to -1 is -15. So -15 will be the gradient of the tangent. So if I simply sketch here, can sketch that is the curve, and then we have that is the tangent, and this is the point where we have x is equals to -1. So the gradient is already given. Now the normal is the line that is perpendicular. This one is the normal, it is perpendicular to the tangent. So that means if we have the gradient of the tangent, we can call this m1. The gradient is -15. So we can get the gradient of the normal, because you know that when two lines are perpendicular, the product of the gradient should be -1. So if the gradient of the tangent is -15, then the normal, which is perpendicular to the tangent, that is m2, it will be 1/15. So already, since you are getting the equation of the normal, we already have the gradient of the normal, which is 1/15. So gradient of the normal is 1/15. That is the normal. Now for us to get the equation, we need the gradient and at least one point. So we have, this one is a common point, this point here at x is equals to -1. We need to get that point, and we are going to get the y coordinate using the equation of the function of the curve. Function of the curve is y is equals to is here x cubed plus 5x squared, x cubed plus 5x squared plus px. Remember we got p is -8, so substitute it there. So that will be -8x. Substitute p is equals to 8 in that function, so that will be -8x. -8x. We're simply substituting it here because we already have p as -8. Then -18. So we need to get this point. So when x is equals to -1, what is the corresponding y value? So just substitute. So we have -1 cubed plus 5 -1 squared minus 8 -1 minus 18, like that. And this one will give, using a calculator, this one will give -6. Give -6. So when x is equals to -1, y is equals to -6. So that point, that common point between the tangent and the normal, is the coordinates of that point is -1, -6, and we have the gradient. So having this point and this gradient, we can get the equation. So to get the equation of that normal, I will simply introduce another general point xy, and then using these 2 points, this just xy is just a general point on that normal. So using these 2 points, I can calculate the gradient, which I already know it is 1/15. So the gradient you calculate it by changing y. So y subtract -6 will be y plus 6 over the change in x subtract -1 be x plus 1 is equals to 1/15. So cross multiply these, so you have 15 y plus 6 is equals to x plus 1, and this will give 15y plus 90 is equals to x plus 1. So I want to leave it in the form y is equals to mx plus c. So 15y is equals to x minus 89. So y is equals to x over 15 minus 89 over 15. That is the equation of the normal in the form y is equals to mx plus c. Then part B, find the coordinates of the turning points of the curve. Find the coordinates of the turning points of the curve. So at turning points, of the curve, one thing you're supposed to know is that the gradient function will be equal to 0. The gradient at the turning point of the curve is equivalent to 0, and therefore we need to take this function. It is already here, the function here. So, and then we differentiate that function. The function is here. Let me write it again. So we get the gradient function. The gradient function, by differentiating this, you get 3x squared plus 10x, then subtract 8. We are differentiating y with respect to x. So at turning points, gradient is equivalent to 0. The gradient function is equal to 0. And therefore, when you solve this equation, it will give you the x coordinates of the point of where we have the turning points. When you solve this equation, you will get the x coordinates of the turning points, and then you're going to use the x coordinate to get the y coordinates, and that will give you the point. So you solve this. There's no way you can simplify this one further. You can use any suitable method. Let me use factorization. Look for two numbers whose product is negative 24, and the sum should be 10. Those numbers are negative 2, and 12. Negative 2 and 12 will give that. So this will give 3x squared plus 12x. 12x minus 2x is the same as 10x minus 8 is equals to 0. Let me factorize. So 3x is common, x plus 4 minus 2 is common, x plus 4 is equals to 0. So these will simplify to 3x subtract 2, and then x plus 4 is equals to 0. So you get two values. So 3x minus 2 is equals to 0, and here you get the first x coordinate of the turning point, which is 2/3, and then when x plus 4 is equals to 0, here you get the x coordinate to be negative 4. So these are the x coordinates of the turning points. Now we need to get the corresponding y coordinates, and how are we going to get that? By simply equating these x coordinates in the function of the curve. Function of the curve is here. It is here. So y is equals to x cubed plus 5x squared minus 8x minus 18. So when x is equals to negative 4, what is the corresponding y value? Simply substitute y is equals to negative 4. Substitute x is equals to negative 4 in that function. 5 negative 4 minus 8 negative 4 minus 18. So working out this one using a calculator, you'll get this one to be 30, and therefore the first turning point will be when x is negative 4, y is 30. So that is the first turning point. The other one, when x is equals to 2/3, so simply substitute there. So y is equals to 2/3. We are substituting it there. Cube plus 5, 2/3 squared minus 8, 2/3 minus 18. So again, be very keen here. Avoid the decimals. Use fractions using a calculator. This one will give negative 20 and 22 divided by 27. So the other turning point therefore is when x is 2/3, y is negative 20 and 22 divided by 27. So these are the turning points. These are the turning points. So this one and this one. So those are the two turning points of the curve.